Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afihika bin Mahyudin from Bmmm section 1 and my metric number is B092010066. Today I will present about the assignment 2 of Bmmm 2333 Pneumatics and Hydraulics Technology, which is I choose system 1 for this assignment. The question for the system 1 is a company makes a range of hooks from flat plate for use with climbing gear and safety equipment as shown in figure system 1 below. The outline shape fits into a rectangle approximately 100 mm by 150 mm. The last part of the manufacturing process is to twist the hook by 90 degrees. A mechanism is to be custom to the following sequences as follows. The number 1 is the hooks are manually loaded into a magazine. Then the hooks are fed one at a time into the clamp with the hook end sticking out. Then the chuck is advances and then grips the hook and then twisted. After that, the clamp release and the chuck returns, pulling the hook out of the clamp and then drops into the bin below, and finally the cycle is repeats. This is my design, my electropneumatic design for circuit for this case. The first one, when the push button PB1 pushed by the operator, the 542 valve 1V1 will actuated by the solenoid. It will allow the compressed air from the air service unit to flow and the pump will advance. Then the advanced clamp will hit a roller A plus at the 5-way valve 1V4. Then when the valve 1V4 actuated, the air will flow and allow the double active cylinder 1F4 to advance. The advancing of 1F4 double active cylinder will hit the roller A2 at the 5-way valve 1V2. So the 1V2 valve will actuated to allow the chuck to advance and grip the hook. After that, when the hook was gripped, the roller of B plus will censor the 5-way valve 1V3 to actuate. The actuator of 1V3 valve allowed the air flow to rotate the hook by the semi-rotary actuator 90 degree clockwise. For the retracting process, when the push button PB2 pushed by the operator, and the solenoid Y6 will function and actuating the 5-way valve 1V1. The actuated 1V1 will retracting the clamp once the pressure low at the clamp, and then the advanced shaft will retracted. After that, the chuck shaft will retracting and the air will flow out to the exhaust. Then the hook will release and drops to the bin below. Then the semi-rotary actuator will rotate again back to the normal position because the spring return will actuate the 1V3 valve and allow the airflow to the exhaust. And all of this step will repeated as the cycle. Here is the simulation on how my circuit done or progress. Alright. For the advancing, and when the push button PB2 press, this is what happened. Alright, this is how my design function, and that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. My name is Muhammad Hazim Aiman Hasman from Bmmm 101. My number metric is B0920101111. Okay, now from the assignment, I choose the question number 2. The diagram below shows an outline design of proposed machine to be used for drilling a hole in a workpiece that works as follows. First, the workpiece is put in position. Next, the guard must be lowered and the workpiece clamped by cylinder C. 3 seconds after the guard is lowered, the drilling commences automatically. The workpiece is fed against the drill by cylinder B, and this is double rod type cylinder with the rod fixed at each end. The speed of the feed must be controllable. Okay, this is my circuit for question number 2 by use pneumatic sim. Okay, now I will show you how the circuit function. Okay, first we need to clamp the workpiece by use the clamp cylinder. Okay, we push the button. When the valve 1B5 is actuated by solenoid K3, this piston in the cylinder 1S1 extend. The workpiece was clamped. Okay, after that, when push button is pushed, the valve 1B1 is actuated. The piston in the cylinder 1C1 extend from the A0 and touch A1. After the cylinder 1C1 touch A1 in 3 seconds, the valve 1B4 is automatic actuated and piston in the cylinder 1C1 and 1S1 extend. The motor spin drill was detected by sensor at cylinder 1C1. Okay, lastly, the valve 1B4 is actuated by solenoid 1M2 and the cylinder 1C1 and 1S1 retracted. So from that, we can adjust the speed of motor drill. Okay, so that's all for me. Thank you.
Hello, my name is Surendran Balakrishnan. My metric number is B0920103884. Among there got 5 systems over there, and I choose system 3 as my task. I explain what is system 3 actually about. System 3 shows a tube swagging machine. A tube is placed on the rest. The process start button is initiated the process. The 2 end cylinders that acting at low pressure to advance and center the tube. This continues to the clamp cylinder to operate at high pressures. When the clamps are in place, the pressure at the end cylinders increase to force the end further and swag the tube and its both ends. The stop button is initiated and this makes the end cylinder retract followed by the release of the clamp cylinders. A rotary equator ejects the tube into a receiver box. This is how the system works. So I have designed a circuit using fluid sim. Let me show the design. Okay, this is the design. Let me play the fluid sim. This is how it works. Let me explain. The tube actually placed at rest at first, so double acting cylinder is acting as the end cylinder at low pressure. So then at one end center the tube, so the 2 piston draws double acting cylinder representing clamp at high pressure. So then once the 2 piston double acting cylinder in place, the pressure at double acting cylinder is actually increased and it forces out and swags the tube and its both ends. So let me show the process. The push button actually work as, I show the design again. Okay, the push button actually work as the stop button. So when the push button is pressed, it is initiated and the result to make the double acting cylinder retract, followed by 2 piston, double rod acting cylinder. When we play again, when we press the close button over here, this double acting cylinder retracts and the 2 rod piston double acting cylinder also retract. So finally a semi actuator, which over here the semi actuator will proceed to eject the tube and over the top one, the tube at the top one. So as a conclusion from this experiment, I learned to design a circuit using fluid sim, which show the from the system 3 I learned to do the fluid sim using this system 3. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Layana Salihah binti Mamano. My metric number is B0920102113. I choose system number 4. The design pneumatic system for furnace conveyor in feature below that works as follows. The process initiates when the start button actuated. The furnace door is open and the trolley moves back GMM and drops the object into a tank underneath. The door must be closed as soon as possible to reduce head loss. The trolley moves forward 15 cm to its normal position. Note that the trolley can be moved by 2 cylinders as shown in the figure to have the position required. The door is operated by a motor and lead screw arrangement. This is my solution. In the pneumatic component, I use a service unit, 4 two-way solenoid valve with roller, 4 two-way roller with spring return, 3 double action cylinder. In the electro-pneumatic circuit, I use electrical connection 24 volt and 0 volt, push button, relay and solenoid. When the push button is pushed, the valve 1V1 is actuated by solenoid K1. The piston in the cylinder 1C1 retract from the rod end to the blunt end of the cylinder and touch the roller of A1. After the roller of A1 touched by the cylinder 1C1, the valve 1V2 is actuated, then the piston in the cylinder 1C3 extend 15 mm from the blunt end to the rod end. While the piston in the cylinder 1C3 is extend, the piston in the cylinder 1C2 retracts 3 mm. When the piston in the cylinder 1C2 reach at the blunt end, the piston in the 1C3 touch the roller of A6, and then the piston of the 1C1 extend again. Here I show the simulation of the circuit. That's all for me. Thank you.